Okay, so we finished up learning about the laws of exponents. Today we're going to be talking about simplifying radicals using prime factorization. So anytime we have a radical that is not a perfect square, that means it's rational and we have to write it in its simplest form. So there's a certain method we're going to use to do that. The first thing we're going to do is divide the radical by its prime factors. Okay? If you remember, a prime number is any number that's divisible by itself and 1. Okay, so we could say that our prime factors would be 2, 3, 5, 7, 11, 13, 17, and so on. Okay, there's many more we could use, but we don't need to get up that high. These are our basic prime factors that we're going to be dividing by. Okay, so once we divide by the prime factors, for every pair that we see, we're going to bring one of the factors out. Okay, and then whatever is left over, we're going to multiply whatever is on the outside of the sign and multiply whatever is inside if necessary. So let's actually try this real quick. If we have the square root of 28, that's not a perfect square, so we're going to have to simplify this. So what I'm going to do, I'm going to rewrite it right over here. I'm going to divide 28 by one of these prime numbers up here that we just listed out. Okay. I know that 2 goes into 28, so I'm going to divide 28 divided by 2. Okay? So once we divide 28 divided by 2, we should get 14. And we can divide 14 again by 2. And if we divide 14 divided by 2, we get 7. Okay? Now since 7 is a prime number, right? 7 is a prime number, so I'm going to stop there. So we just did the first step. The second step said that for every pair of like terms, or for every pair of like factors, we need to bring out one of the factors. So you can see, here that we have a group of 2's. We have a pair of 2's. So I'm going to take those 2's outside of the radical, but I'm still going to leave that 7. Okay? That 7 doesn't have a pair, so it stays inside. One of the other math teachers told me before that couples go out, singles stay home. Okay? So the 2's are a couple. They're going to go out on a Friday night. 7 is a single. He's going to stay home alone. All right? So that would be our answer, 2 square root of 7. So let's see if we can do square root of 54. Again, that's not a perfect square, so let's see if we can simplify this. I would take 54, and I want to divide it by one of my prime factors. Okay, there's a couple that would work here. I could divide it by 2. I could also divide it by 3. So let's divide by 3. 54 divided by 3. Should be 18. And then I can divide 18 again by another prime factor. Well, I could divide 18 by 2. I could also divide it by 3. I'm going to divide by 3 because that's my bigger number. And it'll make it a little easier for me. So 18 divided by 3 would give me 6. And I can still keep dividing here. I can divide 6 by 3 again. And this time I will get 2. Now 2 is a prime number, so we're going to stop there. So again, we did the first step here, which was dividing by our prime factors. And now I want to look for every pair of like factors. So let's see, I have a pair of 3's here, so I'm going to bring that outside of my radical. And then I have a 3 and a 2 left over. Okay, those are not the same factors, so those are going to stay inside the radical. They're going to stay inside the radical, but they're factors, so that means we have to multiply them. So now, if I want to write this as my final answer, I would have 3 square root of 3 times 2, which is 6. So 3 square root of 6 should be my answer. Okay, why don't you try the next 3? Why don't you pause this for a minute, see if you can simplify the next 3 square roots. Okay, so if we simplify 24, square root of 24, real quick, I'm just going to list out my prime factors. Remember, we had 2, 3, 5, 7, 11, 13, etc. Okay, so I have 24 here. I can divide that, I want to do it by my biggest prime factor, so I'm going to do 3. So 24 divided by 3 gives me 8. 8 can be divided by 2, which is 4. And 4 can be divided by 2, which is 2. So we just listed out all the factors. I'm going to stop at 2 because it's a prime number, and now I'm going to look for all my pairs. So I have a pair of 2's right here. That can come out. And then I have a 3 and a 2 left over. My 2 leftover factors go inside the radical, and I'm going to multiply those together to get my final answer. So my final answer would be 2 square root of 6. Okay? For square root of 32, let's go ahead and just divide this by 2. So if I divide 32 divided by 2, let's see, 32 divided by 2 would give us 16. I can divide 16 by 2 again and get 8. 8 can be divided by 2 and we get 4. And 4 can be divided by 2 and I get 2. Now I'm going to stop at 2 because that's a prime number. So we have lots of 2's now. I'm going to see if we can find different pairs. So I have one pair of 2's here, so I'll write that outside. And I have another pair of 2's. So I'm going to write those outside. Now remember, these are factors, so we have to multiply them. And I have a 2 left over. So that's going to go inside my radical. So now if we simplify that, we would have 2 times 2 outside, which is 4. And inside the radical, we have square root of 2. All right, and our last one, 200. Okay? We could divide 200 by 2 and keep going from there, but I know that 200 is also divisible by 5, so I'm going to start with that one so we have less steps. So 200 divided by 5 would give us 40. And 40 can be divided by 5 again. That would give me 8. 8 can be divided by 2, which is 4. And 4 can be divided by 2, which is 2. And we'll stop there because it's a prime number. So now I'm going to find all of my pairs. I have a pair of 2's and a pair of 5's. So those both come out. And then I've got a single 2 left over. So my final answer, if I multiply 5 times 2, will be 10 square root of 2. Or you can read that 10 rad 2. Okay, the last rule we're going to talk about for simplifying square roots is when they have variables. So what you want to do is divide the exponent by 2. You're going to bring that outside, and then whatever the remainder is stays inside. So if we were to look at this first example here, or square root of x to the 6th power. Okay, what this really means is that we have square root of x times x times x times x times x times x. Okay, now we still are taking out a pair. We're taking out pairs at a time, right? So if we were to take out all of our pairs, I have a pair of x's here, a pair of x's here, and a pair of x's here, right? So wouldn't that be x times x with nothing left underneath? So in other words, that would be x to the 3rd power. That's my final answer. Okay. Now for the next example over here, the square root of x to the 9th power, if I were to write all of that out, if I were to expand it, it's going to take a minute. I think we have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So if we were to expand this all out, which you don't have to do, I'm just showing you this for visual, so you have a little bit more of an example here. If we were to take out all of our pairs, if I were to circle, I have a pair here, a pair here. I have 4 pairs of x's. So I would take all of those x's out. And then I have this one little x left over. Okay? So if I were to multiply all these x's times each other, we would get x to the 4th power and square root of x left inside. And that would be my final answer. Now instead of listing all those out, all we have to do is divide by 2, and then if there's any remainder, we leave one of those variables inside. So let me show you our first example. Square root of y to the 10th power. Now it's nice when we have even numbers because it means we're not going to have a remainder, right? Every even number is divisible by 2. So if we were to simplify this, we would do 10 divided by 2, and we would get y to the 5th power. Okay? That would be my final answer. For the next example, square root of a to the 5th, okay, we would divide that number by 2. And we know that, let me clear this out real quick. Whoops. We know that 5 divided by 2 is not going to be a whole number, but it would be 2.5, okay? So all we're going to do here is take out a squared, and because there's a decimal here, we'll leave an a inside. Okay? So because our answer was 2.5, we took out a 2, and then we left a variable inside. So let's try the last example here. Square root of x to the 5th, y to the 8th power. So I'm first going to do the x's. If I do 5 divided by 2, again, I'm going to get the same answer as we just got for this last problem. So 5 divided by 2 would be 2.5. That means I'll take out an x squared. And I know that I'm going to have an x left over in here. And then I'm going to divide 8 divided by 2 for my y. So we know that 8 divided by 2 is going to give us 4, right? Hopefully we all know that. So that means we get y to the 4th power, and there's no remainder, so there's no y left inside. So this would be my final answer. X squared, y to the 4th, square root of x. Okay. Now it looks like we've got one more example down here. Let's take a look. Ooh, this time we have square root of 25, y to the 5th power. So the first thing I'm going to do is take the square root of 25. Hopefully we all know that the square root of 25 is just 5. But then we also need to take the square root of y to the 5th. So I would do 5 divided by 2, and we get 2.5. So I bring out y in that 2. And because there was a decimal, there was a remainder, I'm going to leave a y left inside. And that would be my final answer. So take a minute, pause the video, and see if you can answer these next few problems on your own. And these should be our final answers. If you have any questions on these, don't worry about it. Come to class and we'll go over it. Maybe pause and go back, see if you can understand some of the examples a little bit better now. But hopefully you have a better idea of how to do this, and we'll talk about it when we see you next.